feel bad for my computer. It must be having the worst year ever. If it was part of a union, if the robots ever rise, they will complain that it was because of this year, the amount we're pushing our computers. All right, so we have, it's a normal distribution. So again, put that graph in there. So the average is 63.6 and standard deviation of 2.5. So you would just label that right in there. You can just go ahead and say, all right, we know it's 63.6 inches. And we know the standard deviation is 2.5. So that's usually that's the first step, right? Just find these numbers, throw that in there. And you have to be between 58 and 80 in order to, like, even just fit inside some of these airplanes, right? That's usually why they have height requirements. And we'll figure this out later on in terms of, even like an airline, when they design their seats, how much room do you need between seats in order to fit somebody's leg? This is the same type of question. So between 58 and 80. So 58 would be somewhere over here. We don't know exactly where. It looks like it's going to be a little bit further down maybe, but again, it doesn't matter. This is just a sketch to kind of, let's say, one standard deviation is 2.5. So let's say it's somewhere around here. 80 is going to be like way up here, right? 80 is going to be like up here. Find the percentage of women meeting the height requirements. So in other words, how many are in between these two values, right? You have to be between these two values to join. And so the question is, what is the probability of this? Everything in between these two values. So the way you would do that is find the z-scores and then basically, try and cut out that piece of the pie. The problem or the question is, what is the probability of finding somebody between these two values? And your method, or the way you would approach this, would be find a z-score, standardize it's normally distributed, so let's find a z-score. There's going to be two z-scores, so let's call this z-score 1, this one's z-score 2. So z-scores, right, is the your value minus the average over the standard deviation. So 80 and z-score 2. Okay, so we need a calculator. So I'll use my calculator here. 80 minus 63.6 divided by 2.5. So here I get so this is a huge z-score, right? I have a 6.56 here. That's huge. And then this one here, I have negative 2.24. All right, so next step, right? Find the z-score, and then you're going to use the table, right? Or Excel. In this example, let's use because they're asking us to use the tables, right? If you look here, it says use the table. So let's use it when they say to use it. and find the corresponding z-scores. All right, so in the case of z-score 1, this thing is so huge, so it's not even on the chart, right? If you look at the chart they give you, I think this would be on page 2 for positive scores. Right, when you look at this, it stops at 3.5. You can't even get to 6.6. And so what do we do? Well, it says here, for values of Z 3.49 and above, right, for Z above this, use 0.9999, right? So the probability of Z1, right, the probability of your X value being greater than 80 right? Or I guess less than 80 in this case, right? Probability of being less than 80, because that's how the z-score chart works, right? Let's call that this one here. Is 0.9999. Now, what is the probability of being less than 58? What's that going to be? Well, that one's going to work because that z-score of negative 2.24, that'll be on the chart. So negative 2.24, where would that be? So negative 2.2 right here, and then 0, 1, 2, 3, 4. Right, negative 2.2, 0, 1, 2, 3, and 4. So 0.0125. All right, so that's we've got our two probabilities, and then now we can give the answer, right? Our answer, or your conclusion, whatever you want to say, it's going to be, so the probability of X being between these two values will be 0.9999 minus 0.0125. Which gives me 0.9874. For the new height requirements, oh, what's this? If the branch of the military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what are the new height requirements? So this is a good question as well, because you have to do that backwards thing that I was mentioning earlier. There we go, perfect. So if I want the bottom 1% and then the top 2%, I'll have to find the z-score first. So how do I do that? Well, use your chart first. So let's call this z-score 1 here. So what do I know about it? Well, I know the probability is 0.01. So let's find that. So you would have to, so if you want to use that, the expression, I think if you watch that video 19, that one I wanted you to watch, there's something called a critical score that I mentioned, Z alpha. And in this case, Z alpha would be everything to the right. So this is a terminology, this is what's called the critical Z score. You can see that in the video. If you haven't watched the video from last time, that's where I talk about it. And all the other stuff I'm doing right now. The alpha value is everything to the right, right? So if I wanted to use that notation, it'd be Z 0.99. But that's okay. We don't need to worry about that. But again, you could do that, and then all I have to do is look up, this thing on the probability table. So where would, it's going to be a negative Z score. So where is 0.1? So it'd be here and here, I guess. So negative 2.325. Let's take the middle because they're about evenly spaced, so that looks good. Negative 2.325. That's actually a very special Z score that we'll learn later on. The 1% is a special Z score that we use a lot. We'll see later on that that's a 98% confidence interval would be a Z score of that. But for now, let's just write that down. And then this Z score here, what's this one going to be? This is a 2%. Right, this is just the area, and that value there is 0.02. So that Z score you could represent as 0.02, because that's the value to the right. So let's look that up. What would that Z score be? Well, that Z score, again, because it's red all the way here, right? You got to read it from the left-hand side. I'm going to be looking for a value of 0.98. So that's going to be a positive Z score. 0.98, which is somewhere here. Again, they're very close. So let's take the middle. So 2.0, what are these ones? 2.055. All right, now what? Well, now again, this problem we do backwards, right? In the first part, we find the Z score first and then use the chart. In this method, because we're given the percentages to begin with, or the probabilities to begin with, we use the chart first and then now calculate the Z score. So we just do it in the opposite direction. Right now we have the Z score, let's figure out the value. So Z score 1, we can say, so what is this value? Let's do this one first. Call that x1. So Z1 equals x1 minus the average. So Z1, which is negative 2.325. Then we have x1. The average height, 63.6. 2.5 is the standard deviation. So here I get 57.78 inches. Hopefully I did my algebra correctly. And then Z score 2. which is 2.055. Same thing. So so 68.74. So that makes sense. Yeah. It's going to be lower than the other value. All right, now we're done. So these are the height requirements here. This is the small, this is the large. Round to 1 decimal place, okay? So 57.8. And 68.7. All right. There's a probability not from A. So essentially what they're asking is the probability of not from A. Well, you could do a couple of things. You could say, well, that's going to be 1 minus the probability of A. That's a good way of doing it. So let's do that. Let's try and figure out the probability of restaurant A. So the probability of A, right, there's 355 orders from A. We're also going to need the total. Let's get the total number of orders. This is usually a good spot to put it here. We know there's 1081 orders. So the probability of A would be A over the total number, right? So it would be this divided by this. And then, so the probability of not A would be 1 minus this one. And then we would just have to be careful for the number of significant digits. Round to 3 decimal places. So I would say 6. .672. And then, you know, if this was a quiz, you'd want to make sure you read everything properly, right? 1 order selected, find the probability of getting food that is not from A. So yeah, that's good. That means 1 minus from A. Or you could just add up all of these together as well. You should get the same number. Aha, this one. Another classic. In an experiment, college students were given either 4 quarters or a $1 bill. And they could either keep it or spend it. So again, this is a joint probability, right? You could do both. You could get quarters and spend it, or you can get quarters and not spend it. Find the probability of randomly selecting a student who spent the money given, so this is a conditional, right? Whenever you see that word given, you know you're going to be in a conditional probability situation. So again, the best strategy that I recommend to you is to actually, you know, write the formulas out at some point. You can do it in Excel. We can try that in Excel. Why not? since we're becoming good at this. I'm just going to copy it and then see if I can just paste it into my Excel sheet I'm already going with here. Very good. Maybe I'll put on another sheet. Just so we can see everything. And, it's good practice in general to always just have the sums and the totals down here. But again, we can just write down the question first. They want to know, what is the probability? So then when you write it down, it makes more sense. Because and that's part of the learning activity is can you, put the question into a symbol, into a mathematical symbol. So selecting a student who spent the money. So in other words, bought gum or whatever it is, spent the money given that they got quarters. So I'm going to say they spent the money given that they got quarters. And if you look at your formula sheet, there's a way of figuring that out. Right? If you go again to your formula sheet here for conditional probability, right here. So I would need probability of this and this over probability of the denominator. So again, you would say, so therefore this is going to be the probability, and the more you write down, the more I can give you for part marks if you get it wrong. So S and Q divided by the probability of Q. So the probability that you spent it and you were given quarters, so it'd have to be here. Right, because here's quarters and you spent it. So this square, and then I have to divide that by the probability you're given quarters, which is going to be this column here or this row here. So I need this sum anyways. Yeah, I'm going to need that value, right? I'm going to need the total people that spent quarters. Or sorry, that got quarters. So 51 people were given quarters, and 34 of them purchased gum. So you would just say that divided by this sum here. Three decimal places. So again, that would just be 0.667. Yeah, okay. All right, I think I'm good. Find the probability of randomly selecting a student who kept the money. So you kept given that the student was, this is a little confusing the way they word this, given that the student was given 4 quarters. Okay, so that's going to be, to go back here, this would be the probability that you did not spend. So who kept the money? So you did not spend. So I guess I'm just going to go K for kept the money. In other words, did not spend the money, given that they had quarters. So again, we would just use the same formula. So kept and quarters divided by quarters. So the only thing that's different here would be kept and quarters. So who kept the money? 17 people kept the money, and 51 people were given quarters. So point, I guess that makes sense. It would just be the complement. I didn't think about that till now, but who spent the money given that they have quarters? Yeah. Who kept the money given that they had quarters? Yeah. So 0.333. That makes sense. Okay, in the game of blackjack, a player is initially dealt 2 different cards. That's true. Blackjack is when you get one of the 4 aces and then one of the 16 other cards worth 10. The 2 cards can be in any order. So this tells you right now that it's going to be a combination, right? Because it doesn't matter if you get the ace first or if you get the 10 first. What is the probability of being dealt a blackjack hand? So how would you handle this? I might have already done this with some of you because I think this has been flagged before. But in the case of blackjack, that probability of blackjack is going to be the number of blackjack hands over the total number of hands. And so how do you figure out the number of blackjacks? Well, okay, so I need to get out of there's 4 aces, so I need to get one of them. And I need to get out of the 16 cards that are worth 10, I need to get one of those. Right, that's what they tell us in the question anyways, right? They say there's 16 and one of the 16 worth 10. So the problem is that this is how many blackjack hands are possible, right? We could just do that calculation first. Right, the number of blackjack hands would be 4 choose 1 and then 16 choose 1, which is the same thing as 4 times 16. So 4 times 16, there's 64 different possible blackjacks that you can be given. Now the tricky part is how many total different hands. Well, there's 52 cards, and there's a possibility, including the blackjacks. There's 2 ways to pull. It's 52 choose 2. So there we go. So you'd go function 52(2). So there's 1326 possible hands. So 4.8%.